Hi everyone, welcome to this video series on Essential Statistics, a primer for data science and machine learning project. In the previous video, we talked about the context and overview as to why we need to know statistics and maths for data science project. In this particular video, we'll talk about the typical data types that we encounter in statistical projects, or rather data science project, where we have to look at data from statistical angle. So, for example, variable, what are the types of variable, numeric and categorical and so on and so forth. So in this video, we will try and understand the various data types and learn the characteristics of data types and try and categorize them, and also discuss from machine learning point of view which data type is the one or are the ones that we need to focus more in terms of diligence and data engineering or transformation. So firstly, data table in machine learning or any statistical analysis, we have to present the data in a form of a table, which is a structured rows and column. So rows will be your individual instances and the columns are the features or attributes. So a data table is a fundamental block of information in machine learning and statistical project. For example, this is your data of people, and people attributes are given by age, gender, height, and weight, and the class. We'll talk about the class very soon here. Now, this class column is more from the machine learning side of it. So you're saying a person with this attribute is belonging to class of A. Or its class can be male, female, or any other category or suitable category. Each row is an instance or a row or a person. So there are various names for the rows. Typically, it's called records, samples, points, cases, entities. And why do we have various names? Because data science projects are combination study, and it has evolved over the last 6 to 7 decades, where people from or engineers or professionals, doctors, or the postgraduates, they from various field, they came and contributed to the field of machine learning, and that's why you see sometimes we call the record as point as well. Point is a mathematical terminology. Similarly, their record is also a document. So document means, let's say, a PDF, a bunch of text together. Transaction is from the retail world. We have the term called transaction. Similarly, the columns have various names like attributes, features, variables, and predictors. Predictors more from the machine learning side of it. So when we talk about machine learning, we will look at the definition of predictors. So feature types that we are interested in here are can be categorized in multiple ways. So one of the ways is look at the variables from independent point of view and dependent point of view. So for example, let's say a test mark, student test mark would be dependent on how much time the student had given in terms of study or revision or something like intelligence score or IQ score. So independent variables are the variables which define the outcome. And the outcome here is test mark, and that outcome is called the dependent variable, sometimes called outcome, response, or target variable. And independent variables are the columns which contribute to the definition of or the outcome variable. So for example, here revision time and intelligence are independent column. Let's look at few more examples here. Here, if you look at the columns like month, day and week and temperature 2 days before, 1 day before, average temperature for last 7 days maybe or 3 days. So these columns are your independent variables. And the dependent one would be the one that you want to predict, or you want to say that 45 can be defined based on the information in the row. So this is an example of a table with independent and dependent variable. So let's take a couple of more examples here. So in this particular case, you have a loan application. So let's say this field that you have is a loan amount, and you want to predict the loan amount, or the eligibility of the loan amount the candidate is eligible for. And that would be dependent on, let's say, the gender, whether the person is married or not, number of dependents, education level. So these are contributing column towards the loan amount eligibility. So this is another example of a table with dependent and independent. One more column, one more example is automobiles here. Here, let's say we are interested in predicting how many kilometers per liter the car will run, depending on the variables like how many cylinders it has. How more the cylinders, slower the car, or lesser the mileage, and higher the horsepower, it takes more energy. So that's an example of another table or tabular representation or table data with the independent and dependent columns. Let's see one more example. So this is similar to what we just saw. Let's look at this is interesting example here. So what would be the dependent and independent column? We have representations like month, and this is the number of jobs being filled. So what we're saying is, we are predicting, let's say, the number of jobs filled for this particular month, and that could be dependent on last four, independent, values. So these would be your independent, column x1, x2, x3, and x4, and we are predicting this particular one. Likewise, this could be the dependent one, and the last four could be the independent. So this is called sequential data, or is also called time series data. So other example of time series would be something like sensor data, which you get from the sensor machines, or it could be the medical patient data from the sensory devices or medical devices. Those also produce time series data. So data which is associated with date and time in terms of some pattern, that is called time series data. So I hope those were sufficient examples to understand a tabular representation. Even the text data has to be converted into a table for analysis, machine learning, or statistical analysis. Let's say this is a textual data where the data or can be review comment, or it could be some SMS, you know, and the outcome column is defined here. Let's say this particular text is neutral, positive, negative, or stuff like that. And then we have to convert this text to structured column representation. So this kind of columnar representation from the text data we will be covering when we talk about text analysis. So that was about table. Now features. So there are different type of data, or features are nothing but columns that we handle. So numerical feature like age, temperature. Categorical feature, we will be defining what is categorical feature. Typically, it is to do with categories like vehicle type, vehicle color, region, district, computer type, equipment category, and so on and so forth. So those are called categorical variable. Textual features is documents, sentences and paragraph. Date and time features, which are for date and time, temporal in nature. Boolean features, true and false, are Boolean features where you have, let's say, gender, male, female, quality check passed, yes or no. So those are examples of your Boolean feature. Geospatial feature has to do with longitude, latitude, geographical space. Image and video features are, for images and videos. Audio features for speech signals, speech data. So for typical, data analysis, we will need essentially the numerical feature, categorical feature, and Boolean sometimes. And for special applications, you might deal with geospatial, or special applications can be image and video. Special application can be audio. And derive features is a common process, where you derive new columns or new features from the existing one. So let's look at each of these type numerical features. So the definition of numerical features, which is continuous in nature, that means decimal, that means float. For example, height, temperature. They can assume any value within a given range, natural range or permissible range. Other one is discrete numerical variable, where it cannot have any infinite, infinitely, different types of values. It will have values which are specific, discrete, and countable. You can count, for example, number of children, number of furniture, number of bed, number of cars, number of students, number of website visitors, and so on and so forth. Numerical features can also be looked at in a different way, which is called ratio variable, where the variables have a true 0 point. That means there is a origin which is a true origin. For example, height 1.7 centimeter, 1 meter 70 centimeters. That has a true zero. There is a 0 point. But for example, let's say when we have temperature measured in centigrade, and temperature measured in for Kelvin, that's different, or Fahrenheit is different. They do not have absolute zero. So what it means is that 0 degree centigrade is not same as in terms of degree Fahrenheit. They have different measurements. So absolute zero would be 0 Kelvin, right? So in such cases, we call that variable, although it's numeric, is also called interval. But most of the time we deal with, 99% of the data or 90% of the data would be ratio variable. So let's move on to the discrete variable. Discrete means something that you can count, that has a very specific value. The examples are number of students, number of cars, number of items. Categorical variables, which are similar to discrete, but this is slightly a broad category, and or broad categorical type. For example, colors, type of fruits, or type of payment methods. These are examples of categorical variable. A type of categorical variable can be ordinal, which has an order. For example, yeah, let me show you the example, then I'll define it. So examples would be like, let's say, education level. Um, High school, associate, masters and PhD. If you see here, there is a natural order or logical order, but this order does not mean the differences in the order is not same. That means the difference between high school and associate, or associate and a bachelor's, is not a constant or not even multiple. So that magnitude of difference is really not there in cases of ordinal. So what you have is just the natural increasing order or a decreasing order. Some more examples of this is socioeconomic status, low, medium, high. Customer satisfaction rating, poor, fair, and good, and so on and so forth. You can see there are progression, right, in terms of the order. Another type of categorical variable where there is no order, and that's called nominal variable. Let's take an example first. The type of fruit. There is no order. I mean, apple, banana, orange, payment method, there is no order, right? So countries, no order. So where we have no order, that is called nominal variable, or there is no arithmetic operation applicable in such cases. Even the previous case with ordinal, you have limited arithmetic operation. You cannot have whole range of addition, subtraction, and multiplication, and so on and so forth. One more type of categorical variable, you can call it categorical, or you can call binary or dichotomous. It has only two categories, like pass, fail, success, or accept or reject. Typically yes, no type of variable. Smoker, no smoker, something like that. Yes, no. So this is all about the feature types, and you can test your understanding. You can pause the video for a moment and take a look at the questions. In the next video, we'll talk about one of the most important topics, population and samples in the field of statistics. We'll see you in the next video.